In this video, we are turning our attention to section 2.4 and looking at quadratic functions, specifically the standard form of a quadratic function. Okay, your standard form will follow the format f of x equals ax squared plus bx plus c. And what makes this function quadratic is the fact that that leading term there, ax squared, has a power of 2. Okay. Also, think of it like this. We're basically taking our linear functions that we've been studying so far in this unit, and by adding that front term of ax squared into them, we are changing from linear to quadratic. Okay. Now, the numbers a, b, and c in this function, they represent real numbers, and of course, a cannot be 0. If it were, then we would be linear. Okay. Now, the domain of any quadratic function is all real numbers, right? Meaning you can plug any value you want in for x into the function and you will get a result out for y. And you should know already from previous experience in earlier courses that the graph of a quadratic function is a parabola that has an axis of symmetry to it. All right, so you can see the parabola graphed up in the top right portion of your screen in blue, and your axis of symmetry would be that green vertical line that is passing through the parabola. And notice it divides the graph in half by passing through the vertex of the parabola, okay, which is right here. This is your vertex. All right, now a couple rules, and these go along with our transformation rules. When your a value of the function is positive, we know that the parabola will open up. But if the a were of negative value, the graph opens down. Okay. In order to graph a function in standard form, here's what you're going to do. You are going to locate some specific information. You're going to find the x-coordinate of the vertex of your parabola by using the formula x equals negative b over 2a. For now, in this particular video, I just want you to take that at face value, that that's the formula we use, and then in our next video, we'll see why this is the formula, okay? So this gives you the x-coordinate of your vertex. It also gives you the equation for your axis of symmetry. Once you have the value for negative b over 2a, whatever that simplifies to, you can find the y-coordinate of your vertex by simply evaluating the function f at negative b over 2a, okay? Then you're going to locate the y-intercept of your function. Now we know y-intercepts are when x equals 0, so if we evaluate the function at 0, that's going to give us the c value, right? The constant of our function will always be our y-intercept. Then lastly, we're going to find our x-intercepts, okay? Our x-intercepts are when y equals 0, when f of x is equal to 0. So we can solve that either by factoring or we can use quadratic formula, okay? So let's get right into an example. Here we have the function f of x equals negative 3x squared plus 6x plus 1. I know that that's going to graph to be a parabola just by the format that it's in, okay? So let's first find the x-coordinate of our vertex as well as our axis of symmetry. To do this, we should identify our a, b, and c values. In this function, a is negative 3, b is 6, c is 1. The x-coordinate of that vertex, we said, can be found with the formula x equals negative b over 2a, which in this case would be negative 6 over 2 times negative 3. So we have negative 6 over negative 6, or positive 1. So once we get that simplified number, that tells me I can put my axis of symmetry right here, draw it as a dashed line, and And now I can find the y-coordinate of my vertex by evaluating the function at 1. So f of 1 is going to equal -3 times 1 squared plus 6 times 1 plus 1. And that's going to give me -3 plus 6 plus 1, which is going to be 4. So my vertex is the point of 1, 4. Let's go ahead and plot that. Okay. Then we find our y-intercept. Really simple. The y-intercept is when x is 0, so that's ends up being the c value of the function, which is 1. So we plot a point on the y-axis at 1, and then we're going to reflect that across the axis of symmetry to give us a third point. In this case, the point 2, 1. Okay. Now, next we want to find our x-intercepts. Okay. Our x-intercepts would be found by solving this equation, setting the equation equal to 0. Okay. If the right side factors, that would be ideal. This doesn't factor though, so in order to solve, I'm going to use the quadratic formula here. Okay. So negative b plus or minus the square root of b squared minus 4 times my a value times my c value all over 2 times my a value. Okay, so now we simplify. Now square root of 48, you can simplify that radical, it becomes 4 radical 3. And then once we pull that 4 out, we're able to divide a 2 from -6, 4, and then the -6 in the denominator. So this becomes -3 plus or minus 2 radical 3 over -3. Now you can leave it like that, or technically, since we have -3 both in the numerator and the denominator, we can wipe out the negative. We can make this 3 plus or minus 2 radical 3 over 3. Okay, so there are two numbers there because of the plus or minus. Those would be the exact values of our x-intercepts. For the graph purposes, that doesn't really help me much, so I would approximate these. Just type them into your calculator really quickly. If I did 3 plus 2 radical 3 and then divided that by 3, I would end up with approximately 2.15. And if I did 3 minus 2 radical 3, then divided that by 3, I would end up with approximately -0.15. So now we can just estimate the locations of our x-intercepts on our graph. Okay, so right there, right there. All right, and here you have it. Okay, now it's your turn to practice. You're going to pause the video. You're going to work through practice 1, which is going to be very similar to what we've just done in this example. And when you're ready, come back to the video, check your work with what I have on the screen.